everyone, welcome to Sangam Tutorials Gubbi online classes for Ncert and Cbse 10th standard. In the last session of right angle triangles, we had solved some very important riders which are being taken from the previous year papers, and some of the questions were taken from the optional exercise of the Ncert textbook. So in today's session, this is the last session on right angle triangles. Maybe from tomorrow we are going with a new chapter. I hope you have got the updates of the changed syllabus of Karnataka State. I have sent everything through WhatsApp, right? So we will follow that very strictly. So according to the syllabus, what it is prescribed for this academic year, polynomials chapter is totally deleted, but we have done it. The chapter is already presented on the online classes, so no problem at all. You have the knowledge. You are at the advantage because you have learned entire chapter of polynomials of 10th standard. So in the remaining chapters we will go in the coming sessions, right? So apart from this, in today's session we will be going with application problems on Pythagoras theorem. So it's a very important one. So these problems I am going to explain you in detail. I will reach until where you have to apply Pythagoras theorem and leave you there, so you have to continue the remaining problem until you get the solution. And the solution, as it is the application problems or the statement problems, you have to represent the answer in the form of a statement, right? So we'll go with the first one. So here, a tree 32 meters tall broke due to a gale. So just imagine a very big tree, wind is blowing at a very high speeds, that's called gale. A tree 32 meters tall broke due to a gale and its top fell at a distance of 16 meters from its foot. Okay, let us draw a required diagram for this. Right, so this is, let us consider this as the tree. The tree is, let us consider it as to be perpendicular to the ground. So let us take this tree as AB, right. A tree 32 meters tall. So what is the height of the tree here? It is 32 meters. So the entire height of the tree is 32 meters. The wind blows in this direction. So the tree is going to break at certain point from the ground, that is above the ground. So here a tree 32 meters tall broke due to a gale and its top fell at a distance of 16 meters from its foot. So let us imagine that the tree breaks here. So it breaks here at point C, let us imagine that. So this entire thing which is here, it is going to fall onto the ground. That is, the top point A is going to meet the ground at some point here. So here this will be the top of the tree which has broken and which has fallen here. So here the top of the tree touches the ground at a distance of 16 meters from the foot of the tree. So this distance is 16 meters here. So here we have to find out at what height above the ground did the tree break. So from the ground, above the ground, at what point did the tree break? So that is we have to find out. So let this be, let us take it as x meters. Let us take it as x meters. So if this entire thing is 32 meters and this is x meters, then AC will be, this will be 32 minus x meters. This will be 32 minus x meters. So as this part of the tree is broken and it has fallen here, so this part will be 32 minus x meters. So here you have to mention the things whatever you have done it in the diagram. So let AB be the height of tree. Let AB be the height of the tree. So let the tree break at point C. Let tree break at point C. So let BC is equal to x meters, then AC will be equal to 32 minus x meters. So again, so let the tree touch the ground, let the top, let us take it as like this, let the top touch the ground at point D. mention that point here. So let it touch the ground at point D. So therefore AC will be equal to CD. AC is equal to CD. So therefore CD will be equal to 32 minus X meters. So this is the required data, because by observing the problem we have drawn the diagram. The description of the diagram, for this you are given your own names, so therefore you have to mention what name is given for what, and you have to substitute the values which is discussed in the problem. So now in triangle you can see here BCD. In triangle BCD, angle CBD is equal to 90 degrees. CBD is equal to 90 degrees. So by applying Pythagoras theorem, we are going with opposite to the right angle is the hypotenuse, that is CD square is equal to BC square plus BD square. BC square plus BD square. So now CD square is 32 minus X whole square. So 32 minus X whole square is equal to BC square. BC square is X meters, that is X whole square, plus BD square. BD square is 16 meters, that becomes 16 whole square. So here that is 32 minus X whole square is equal to X square plus 16 square. So from here you have to continue the problem until you reach the value of X. So once you get the value of X, that becomes the answer, where the tree broke at a point, that is X is equal to some answer what you have got, such meters above the ground. So this is in the form of a minus b whole square. Expand this, X square plus 16 square. If maybe you are going to get a quadratic equation, maybe you are going to get it. So please solve it by sum and product method and reach the positive value of X, because length is always positive, length can never be negative. So I hope you will continue the problem. Please send me the answer of this problem through the WhatsApp group. Okay. Okay, let us get into the second problem, very important. So this problem is taken from Bhaskaracharya Leelavati book, which is written by the great mathematician Bhaskaracharya of Indian origin. So it is an application problem where the Bhaskaracharya is going to ask his daughter Leelavati a question regarding this question, which comes something like this. So it is in Sanskrit actually, but it is converted into English and it is being presented in front of you. Let us get into this. An insect 8 meters away from the foot of a lamp post. So let us take a lamp post. Let AB be the lamp post. So this will be usually perpendicular to the ground. So this is the lamp post and this is the ground level. Okay. An insect 8 meters away from the foot of a lamp post. Okay. Let us consider an insect here at point C. So this insect is 8 meters away from the foot of the lamp post. So this is 8 meters. This distance is 8 meters. Okay. Which is 6 meters tall, crawls towards it. So the height of the lamp post is 6 meters. So this height is 6 meters here. Okay. So this insect which is at this point C start crawling towards the foot of the lamp post. This is the foot of the lamp post. At present the insect is here. So it starts crawling towards the foot of the lamp post. Okay. After moving through a distance, so it takes certain time, because to cover a certain distance we need time for that. So after moving through a distance, its distance from the foot of the lamp post. So this is the coincidence here. Its distance from here, you have to read it very carefully. Its distance from the foot of the lamp post is equal to the distance it has travelled. So let us imagine the insect was at this point. So it has started crawling towards the foot of the lamp post. So when it comes to this point, for example, for this, okay, let us take it like this. When crawling, it comes to this point, at this point, particular point D. So now the distance what the insect has travelled, now it is equal to the distance of the insect from the top of the lamp post. That is this distance. So this distance has become equal to this distance. So this is equal to this. So this is the thing. So the distance traveled by the insect in that particular time, right, is equal to the distance of the insect from the top of the lamppost. So that is very important. So how far is the insect away from the lamppost? Now, as this happens, you have to calculate at what distance is the insect from the foot of the lamppost. That is, we have to find this. So let us take it as, let it be at x meters from the foot of the lamppost. So this distance will be, as it is entirely BC is 8 meters and this is x meters, so we will take it as 8 minus x meters. Let us take this as 8 minus x meters. Just to complete the diagram, we are going to join this AC. Right. So now, as this distance is equal to the distance of the insect from the top of the lamppost, so therefore this distance is taken as 8 minus x meters. This is taken as 8 minus x meters. So now, we can go with, I hope you can write your own language of introduction here. So let AB be the height of the lamppost. Let the insect be at point C. Let the insect move towards the foot of the lamppost and reach point D. Then BDC is equal to AD. So let BD is equal to x meters. Then DC is equal to 8 minus x. But DC is equal to AD. Therefore, AD is equal to 8 minus x meters. So now consider this triangle, that is triangle ABD. So you have to write the introduction for that. What are the statements you have to write? You have to write all the statements. So we will take this triangle. So in triangle ABD, angle ABD is equal to 90 degrees. So by applying Pythagoras theorem, we will continue. So opposite to right angle is the hypotenuse, that is AD square is equal to AB square plus BD square. Okay. So AD square is 8 minus x whole square. 8 minus x whole square is equal to AB square is 6 meters. Okay. Plus, 6 square plus BD is x meters, that is x square. So here it is in the form of A minus B whole square is equal to 6 square plus x square. So when you are going to expand this becomes 8 square plus x square minus 2 into 8 into x, which is equal to 36 plus x square. So as it is plus x square and plus x square, you can cancel these two terms. So this may happen in the previous problem also. So please continue with this, do some simple simplifications and find out the value of x here. So now he is asking you how far is the insect away from the foot of the lamppost. So therefore, what the answer you get on solving for x, so don't consider the negative value, take it as the only positive value. Here you are not going to get any quadratic equation, you will get a linear equation in one variable, solve it, you are going to directly get the value of x. So see that x is always positive. So if you are getting any negative answer there, so some mistake has happened, so please see correct the things. So what are the things you have to do? You have to write what is AB, you have to write what is BC, you have to write what is BD, you have to write what is DC and write what is AD and their values. And then select the triangle, write the right angle, apply the Pythagoras theorem and reach the answer. And the answer should be written in statements. Right? I hope you will send this tomorrow through WhatsApp. Right? Okay. So let us get into the third application problem, very important. So this problem is also taken from Bhaskaracharya's Lilavati book. So where it is in Sanskrit and converted into English. It's a very beautiful problem. Right. So a lotus is 20 centimeter above the water surface in a pond. Just imagine a pond, and you can imagine a lotus which is above the water surface. The part of the stem is above the water surface and the remaining part is below the water surface, right? So this is how we have to imagine. A lotus is 20 centimeter above the water surface in a pond. Okay, let us take the water surface like this. This is the water surface, right? The lotus is 20 centimeter above the surface, water surface in a pond, and its stem is partly below the water surface. Okay, so let this be the flower. Okay, let us take this as a flower, lotus flower. So the part of the stem is above the surface of the water and a part of the stem is below the surface of the water. This is water surface we have to consider. Okay. As the wind blew, okay, let us imagine the wind is blowing in this direction. As the wind blew, the stem is pushed aside. So a moving wind has kinetic energy, so that kinetic energy is transferred to the lotus. So this entire lotus is going to bend. That is, it is being pushed aside, so that the lotus touches the water at 40 centimeter away from the original position of the stem. So this is the original position of the stem. As the wind blew, the entire lotus, which is like this, it is going to bend. So it is going to bend in the sense, in this way it is going to bend. And the lotus touches the surface of the water here at this point. At this point there is the flower, so it is bending like in this direction. So here the lotus touches the surface of the water at 40 centimeters from the original position of the stem. So this length is 40 centimeters. So here, as the entire lotus plant comes below the water surface and the lotus touches the surface of the water at 40 centimeters, then this entire length will also be equal to 40 centimeters. This entire length will be also equal to 40 centimeters, because this entire thing is inside water and the lotus touches the surface. Okay. So here, as the wind blew, the stem is pushed aside, so that the lotus touches the water at 40 centimeter away from the original position of the stem. A lotus is 20 centimeter above the water surface. This particular point will take. So from here to here, so it is 20 centimeters at this point. From here to here it is 20 centimeters. Okay. So the stem is pushed aside, so that lotus touch the surface, touch the water at 40 centimeter away from the original position. So this is not 40, this is 40, right? So this is not 40 here. So we'll take this as the wind direction. So let this be 20 centimeter above the surface of the water, and we have to calculate originally how much of the stem was below the water. So you have to calculate this distance. Let this distance be x centimeter. So this is x centimeter. So from here to here it is 20 plus x, and this entire thing is now below the water. So this becomes 20 plus x centimeters. This distance will be 20 plus x centimeters. Now the lotus is perpendicular to the water. You can see here at this point it is perpendicular. You can see here. So if you take it as AB, if you take this point as C, and if you take this point as D, so in triangle BCD, you can see a right angle triangle here. So in triangle BCD, BD square is equal to CD square plus BC square. When we apply Pythagoras theorem, so it is 20 plus x whole square is equal to 40 square plus x square. So please solve this equation by applying Pythagoras theorem. So you are going to get the answer. So where you are going to get cancel x and x somewhere, that will result in a linear equation in one variable. So solve the linear equation, you are going to get the value for x. So that x what you get will be the length of the stem originally, which was below the surface of the water, right? So here these are the three very important application problems. So these application problems are not in your textbook, just to complete the chapter of right angle triangles, including in the first step numericals, then with riders, then with identities and application problems. I have completed the entire methodology of presenting a chapter in front of you. So here most of the application problems what they are on right angle triangles are taken from the very famous book Bhaskaracharya's Leelavati. So in the Ncert textbook, in the old textbook there were some problems. In newer textbook we don't find any application problems here. Just one gale, the gale problem, some one for 2 marks, one particular question is there, that's all. So that already it is presented in the previous sessions. So with this session I am going to complete the right angle triangles chapter So from tomorrow's session I will be going with a new lesson in mathematics. So I hope you all enjoyed the entire chapter here. Please practice all the problems. So this Sunday please write a test on similar triangles including right angled triangles. So entire chapter you are going to write a test on Sunday, right? Please get ready for the test. Solve these problems and send it to me through the WhatsApp, right? So thank you everyone. Stay home, stay safe and keep learning.